sometimes choosing what to be u is a matter of trial and error, but there are some patterns that you can look for. Keep in mind that when I find u, I'm going to take the derivative of u, and then that's what I'm going to use to make the substitution. So the derivative of my u needs to be in my integrand, in this part right here, and only need to be fixed by a constant. I can fix a constant, I can't fix a variable. Okay, so if I'm looking at, I only have a couple of options here. If I'm looking at tangent and I'm looking at secant squared, then looks like I want u to be the tangent. Now, not the square root, because if I take the square root of tangent x, if I take the derivative of the square root of tangent x, then I'm going to have power rule, and it's going to blow that whole thing up, and I don't have that much stuff to get rid of in my integrand. Okay, so if I take the derivative of tangent x, then I get secant squared x, and then that's the x right there. Notice that you have that right here in your integrand ready and waiting to be substituted for du. So what's left here is my u, tangent x, to the 1/2 power. That's the same thing as square root. Now notice I didn't have to fix that at all. I didn't have to fix a constant or anything. So I'm ready to take the antiderivative. So I add 1 to the power. I divide by the new power. Dividing by 3/2 is the same as multiplying by 2/3. Don't forget your plus c. And then I just need to take everything back to x's. So I have 2/3 tangent 3/2 x plus c. It's not pretty, but if I take the derivative of that, it will take me right back to the square root of tangent x secant squared x.